Let's look at some techniques for solving logarithmic equations. Now that you have gained the power to rewrite from exponential to logarithmic and vice versa, you now have the power to solve logarithmic equations. Generally, you will do one or more of the following. You'll rewrite as an exponential, you'll express both sides as a log with the same base, or you'll factor. So let's try this out. We're going to find the roots of each equation here. So roots just means the solutions, okay? Notice again here on this question, we don't have a base, so we assume it's a common logarithm of 10. So our method for this one is to rewrite in exponential form. So written in exponential form, we have 10 to the power 3 equals x plus 4. Well, this is a much simpler problem now. 10 to the power 3 is 1,000. And now if we subtract 4 from both sides, we get 996 is equal to x. And there's our solution. Now, always check your work, so you can check by just plugging it into the original question. So log of 996 plus 4, and figure out what that is equal to in your calculator, and you will get 3. And we can figure that out by hand too. Okay, let's look at another example. Again, we'll rewrite into exponential form. So this is 3 to the power 3. So 3 to the power 3 equals 3x minus 7. 3 to the power 3 is 27 equals 3x minus 7. Now we're going to add 7 to both sides. So we get 34 is equal to 3x. Then we divide both sides by 3. And we get x is equal to 34 over 3. Again, good practice. Go back to the original question, plug it in, and make sure it works. Okay, so example 2, solve. Identify and reject any extraneous roots. So this is very aggressive here. We're going to identify and reject extraneous roots. So let's start with solving them. So we have log of x minus 1 equals log of x plus 2. So let's bring the logs to one side and bring the negative 1 here to the other side. So if I bring this negative log x plus 2 to the other side, we have log x minus 1. And we're going to add log x plus 2 here to get it to the other side. So we have plus log x plus 2. And in order to get negative 1 to the other side, we're going to add 1. So now we have 1 on the right side. Okay, the product law of logarithms says that we can take these two parts of the log function and multiply them. So it's the log of x minus 1 times x plus 2 equals 1. Let's rewrite in exponential form now. So we have here, again, a common logarithm of 10. So 10 to the power of 1 is equal to x minus 1 times x plus 2. 10 to the power of 1 is just 10. And if we expand this, we get x squared plus 2x minus 1x minus 2. And we can collect like terms, so we get x squared plus x minus 2. And then bring the 10 to the other side here, and we get 0 equals x squared plus x minus 12. And I'm sure you've missed the concept of factoring. So we're going to factor this because that's how we solve these types of quadratics, or the quadratic formula is another choice. And this can be written as x plus 4, x minus 3, because 4 times negative 3 is negative 12, and 4 plus negative 3 is positive 1, which gives us the middle term there. Remember that the solutions would be x equals negative 4 and x equals 3. Now, let's not forget about this rejection, this very aggressive thing we're going to do. So we're going to check our work now. So if you plug in x equals -4, what you'll get in the original question is you have log of -4 minus 1 equals negative log -4 plus 2. Log of -4 minus 1 is log of -5 minus 1 equals negative log -4 plus 2 is positive 2. And what you may notice and should notice that this is not a real number here. Log of -5 does not exist. So we're going to reject this because we cannot take the log of a negative number. So we take this -4 and we reject it because it is not a true solution. Now let's test x equals 3 and make sure that one works. So we get log of 3 minus 1 equals negative log 3 plus 2, which gives us log of 3 minus 1, which is 2, minus 1 equals the negative log of 3 plus 2, which is 5. And you'll notice that here we have logs of positive numbers. That's okay. We have here a log of a positive number, and that's okay as well. And you can check this in your calculator, and you will get them to equal the same. So there's no need to reject any of these roots. All right, let's try one more example. Again, we're going to solve, we're going to identify and reject any extraneous roots. So, on this one, we need to remember that when you have if you have something like this, the third root of something, that is equal to x to the power of 1 over 3. Or if this is a 2 and we're squaring it, then this is a 2, okay? So let's rewrite this. We would have log of x squared plus 48x, and the cubic root is just 1 over 3 equals 2/3. Well, if we have this, the exponent here is 1 over 3, we can use the power law of logarithms to rewrite it as 1/3 log x squared plus 48x equals 2/3. If we want to get rid of the 1/3 over here, we can multiply this side by 3 and this side by 3. And 3 times a third is 1, so we would just be left with log x squared plus 48x. On the right side, we have 2 over 3 times 3, and 2 over 3 times 3 is just 2. Much simpler statement. So we're going to convert to exponential form. So again, it's a common logarithm, so it's 10 to the power of 2 equals x squared plus 48x. That's 100 equals x squared plus 48x. If we bring the 100 to the other side, we get 0 equals x squared plus 48x minus 100. And again, we look for ways to factor this if possible. So what adds to 48 and multiplies to negative 100? Those numbers are 50 and negative 2. Therefore, the solutions are x equals negative 50 and x equals positive 2. And again, we're going to identify and reject any extraneous roots, so imposters that have come in pretending to be a solution when they're not truly a solution. So it seems to me that negative 50 is probably not going to work. So let's test that out. So we got log of the cubed root of negative 50 squared plus 48 times negative 50. That should equal 2 over 3. Okay, so if we do negative 50 squared plus 48 times negative 50, what we end up with is log of the cubic root of 100 equals 2 over 3. And I actually have no problem with this. Notice that that's positive. We're going to find a cubic root. That's going to be positive as well. We're in a good place. So no problem with the negative 50. So positive 2 must be the imposter. Let's try that out. So log cubic root of 2 squared plus 48 times 2 should equal 2/3. So that would be log of the cubic root of, well, 2 squared plus 48 times 2. That's 4 plus 96. That's also 100. Oh, that's going to work as well. That's just fine. So, in fact, this one has no imposters. All the answers are true solutions. So this is a solution and this is a solution. And if you take a look at the graph of this, it might make it clear why there are two solutions. It's a really unique graph. So this is how we solve logarithmic equations.